is data science? Why is it? Where is it started? Where it started? What is it actually? I mean, the definition, how it is working, who is a data scientist? Okay, a very simple questions. I'm pretty sure that most of you have at least a blur idea of what is all this. Okay, so this is what we'll be roughly covering up in this. Why all the excitement really behind data science and all, and where does the data come from? How to be a data scientist? Who is actually a data scientist? Again, these are all blurred line. There's a blurred line between a data scientist, data analyst, data analytics, everything. Okay, there's actually a very blurry line in between these three domains and all, and these three specializations. So we'll have a clarity of what each things are. Okay, so why is there a big excitement behind data science? Of course, you know that data science is a big word, it's a hype word, and everything is going around in and around data science only. And above all, data analysis has been around for a large while. Like as you could see, we would think that data science is a very recent term and it has all got the hype very recently only. But then it started way back in 1935 when R.A. Fisher wrote a book on designs of experiments. Okay, although the title might look somewhat odd, but this was purely on data analysis. Similarly, in 1939, 1958, 1977, see, this is a very, this topic is like exploratory data analysis, like where you explore and understand what the data is, how to visualize the data, what is actually hidden in the data. Okay, because when you're given with a dump of data, you need to understand first of all what it is, exploring the data. Okay, that is the first thing. That is the very first step. Okay, and that technique came way back in 1977. Fine. And in 1989, there was a topic on business intelligence. And this 1997 machine learning came even before I was born. Okay, so like these are all very, very old techniques, but the word data science has got its hype only very recently, like not more than last 5 years. Okay, and in 1996, Google came, 2007, fourth paradigm, 2009, effectiveness of data, 2010, data village, and in now 2022, we have datafication, dataism, dark data analytics, and lot more. Okay, so those things are not put here, but that we'll discuss at the end of the session. Fine. So you understand this data analysis has been in the domain like for so long, right from 1935. So why all the excitement? Because we have effective and very exciting applications with data science. Okay, earlier when there was case of a particular pandemic, like consider right now we have corona. Way back, like we had many other diseases as well, no? Like there was pandemic due to flu, there was pandemic due to pneumonia. Like these are all very trivial diseases right now. But those days, there was a pandemic because of flu. There was a pandemic because of malaria, because of pneumonia. Such small diseases and all were like a pandemic back then. And they were not able to predict what will happen the next day. They were not able to understand what will happen in the future, when this might go, what can we do, what was the previous cases. All this kind of understanding people back then didn't have, because there was no data analysis, there was no data scientist. Right now we have data scientists who can predict what can happen tomorrow, what can happen next week, next month, next year, 10 years later, 10 decades later. Everything can be predicted. Okay, so that's why the hype is behind the data science. You are able to predict the future, like you are an astrologer come engineer. Okay, that's why the hype is behind data science. So like Google flu trends, there was back then, and then detecting outbreaks 2 weeks ahead of CDC data, like Ebola virus, all this. Okay, when you're able to predict something, then that's really important, no? Like just assume, like right now we have something called as monkeypox. Okay, and people say that this is again going to be a pandemic. Although most of the times, sometimes, uh, okay, people say this monkeypox is going to be a pandemic, and we start thinking that okay, we are going to have a second lockdown, another pandemic coming up. Fine, all of a sudden everything goes down to a normal phase, and say people say that monkeypox is not a pandemic, it is not so severe, and we're not going to have a lockdown. Okay, then like of course for a student level like be it me, there'll be like a bit of disappointment that there's no lockdown, there's no work from home, all that and all. But you know, all this has happened because of the prediction a data scientist did. Okay, they predicted that this is going to be a pandemic, and then someone like in the respective fields like healthcare, they started treating it in that way in order to avoid the pandemic, and now the pandemic is not ineffective. You understand? And this is why the excitement is. This is not only with respect to pandemic situations, with respect to like political campaigns, everything right from A to Z, you can predict everything with a data science. Okay. And when I say data science, you need to include everything right from communication skill to business intelligence to machine learning, deep learning, data analysis, data analytics, and a lot more, including statistics. Okay. But in the outside world, they would say you as a data scientist. But within that, you'll be doing these many things like from ML to statistics to business intelligence, applied intelligence, and a lot more. Okay, but the credit goes to a data scientist. And that's what I told you. If you're working in a smaller organization, you are equivalent to a statistician, to a machine learning engineer, to a deep learning engineer, to a business intelligent agent, and a lot more. On the other hand, if you're working in a bigger organization, for each of these small roles, they will have individual team. Okay, for machine learning engineers, they have a team. For deep learning engineers, they have a team. For statisticians, they have a team. Likewise, they have a team for each and every role. Fine. So data scientist is expected to have a knowledge on all these things. And before we start this course, let me tell you, it's really impractical to be 100% data scientist because everyone has interest and has a knowledge on a specific concept. Like if you ask me, I'm only good in deep learning. The rest all like all bloody knowledge only. The same way, attempting to be a perfect 100% data scientist is beyond impossible. Okay, we're just going on the flow, like learning something on the go, and then implementing them and then doing things. Fine. So this is why we have so much excitement because data scientist is able to predict the future, is able to understand the past, everything. So that's why a data scientist has is always a very exciting career. Then sponsored research. This is one best example of data scientists. Like you could read that point. Google has got a revenue of around $50 billion per year from marketing. And it is like 97% of the Google's revenue comes from marketing only. What? Like you keep surfing and of course, you know that the ads start popping up. Okay. Like if you use Amazon in your laptop, the next time when you search some other materials, again you would see related products coming up in your web page. All this is because they are gathering, you might know all this. Okay, they are gathering your data, they are tracking your data, your cookies, everything. They are understanding what is your interest and they start marketing the products. Okay, this is how things go. Like and when you sign in your I mean, when you have a sign in, right? Maybe the Google sign in, okay, Gmail sign in your phone as well as in your laptop. Okay, like yesterday I was searching a tiffin box for my daughter, insulated tiffin box. In my phone, I was searching. And today morning, while I was browsing the laptop, I was getting all related insulated tiffin box there. How? Because I had a common sign in both my phone and laptop here. So you do some kind of stuff in your mobile, but that kind of recommendation will reflect in your laptop because there's a common sign in. I have signed in both my laptop and mobile with Gmail. So that's why this kind of things come up. So they're trying to utilize the maximum that is available, maximum ways they're trying to promote their products and everything. So this is what a sponsored search is. Okay. So again, this is not only for products, for every other thing as well. Okay. So there are around 30 billion search requests a month, perhaps a trillion events of history between search providers. Okay, a lot much more. And this is a very simple example of Google. You might think that Google is a very big company taking so much of turnover, but you see 97% of their turnover is from marketing only because they are tracking your search history, tracking your search keywords, everything. Because of that, they are earning a lot of revenues. Okay. And where does the data come from? Of course, you know, the data comes from big data. So, and all these terms, I think you might know, it's like it's happening online. Everywhere you have the data. Okay, like earlier, if you go to a hospital, they would gather your data in a paper pen method. Like they would ask you to fill up a form, keep a record of it, everything. Right now, we are taking everything in online. We have online prescriptions, online reports, everything goes online. So right from a very trivial to most essential things, everywhere the data is collecting. Okay, like assume the case of a sensor. Let's consider the case of an escalator or elevator. Okay, a lift. Okay, so you might have heard of many tragic incidents where people have been crushed to death in an escalator. Okay, so sorry, elevator. Fine. So there, the sensor data are actually collected, and they actually gather the data as when and where the accidents has happened, and like in the forthcoming products that would be avoided. Of course, it's a problem of sensor, but still the data are collected. You wouldn't imagine that when you enter a lift, the data are collected. Okay, it is a sensor. You would think that, okay, we are entering a lift, that's it. But even there, the data are collected. And what data could you collect from there? Beyond our imagination, right? So people are leaving no stones unturned. Everywhere possible, they are collecting the data. They are dumping the data. That's it. When you dump the data, there's nothing you could understand. But when you start understanding the data, analyzing the data, exploring the data, you get a meaningful information out of it. Now consider the case of the same thing, lift problems where people are crushed to death. Assume that if and all if the person enters a lift in the mid position, like you know it, right? Like when you want to enter the lift, the first thing we do is we keep our hands on the sideways so that it detects a person is entering, and then it does. In some cases, if the sensor is really bad, even if you keep the hands, it keeps closing. I think you would agree to that. Okay, so that way you need to understand as what kind of defects are over there, like what kind of measurements, everything. And then you would understand, okay, if and all, if this is the case, this is the case, this is the case, then you are going to be crushed. Okay, and also it keeps note of the brands, everything, like how the lift was designed. Every factors would be considered in understanding the tragic accidents and all. Okay, and then we have this Internet of Things, like everything, machine to machine translation, communication, B2B, A2B, M2M, so much more and all we have. So everywhere, typically the data are collected. Everywhere it is collected and it is dumped. We have around, like of the 100% data we have in this whole world, around 80% of the data are unstructured, which means they are just dumping, they are just lying down as a dump. Okay, we haven't started analyzing that 80% of data, and then we haven't analyzed as what is actually there. Okay, now considering the same coronavirus, when we started gathering the data, initially we didn't have a clear picture, but when you started understanding the trend in the data, you predicted that the case is going to rise in a particular place tomorrow. The cases are going to decline in a particular place tomorrow. That way, that kind of trend we started understanding only after analyzing the data. So right now, 80% of the data is unanalyzed. And it is the job of a data scientist to analyze the data and to make meaningful predictions. Okay, now you understand why data science job is required, because the whole world is unresolved right now. You have so much of data and we don't have people who could sit and analyze the data. Okay, at the end of the day, I'll show you a video, like at the end of the session, where they would stress on what actually a data scientist doing. We would think that a data scientist is doing so much of complicated codes, algorithms, and lot more. But in fact, all that they are doing is analyzing a data. The major percent of their time they spend is gathering relevant data and then understanding the data. The algorithm, the coding part, the detection part, prediction part, everything takes place in no time. The major part of time is spent on analyzing and gathering and understanding the data. Okay, so this is what actually a true data scientist doing, but then wherein the hype says that a data scientist is a true coder, a true performer, everything. But in fact, what you're doing actually is analyzing a data. And it would be really a surprise to you if I say you that 90% of the time they are using a very trivial algorithms. Okay, like even in universities for a capstone project, when you're doing so much complicated algorithms, but in industry, all they're doing is a very trivial regression kind of algorithms only. Okay, so there's so much of hype, but when you talk with the IT guy, you would get to know the reality. Okay, like today I'll share two videos with you. One guy would have talked very openly about what the IT industry is and what they're actually doing. Okay, so Professor Saroj sir, he was actually an academician. Now he has went into an IT industry, and he would give you a clear picture of what is actually this and that. Okay, that video I'll share with you. If you have time, you could watch that. And the next is data is the new oil. Like, oil could be like oil is initially useless unless and until you separate it into its basic ingredients. Okay. Fine. So data is the new oil. So like the data is now like a oil. Like as I told you, like oil is like very abundant in nature, but when you start extracting them into useful things, the rest all goes to be a waste. That way, right now, this is a keyword that was published in World Economic Forum in 2011. They agreed that data is equivalent to a new oil right now. Like we have so much of things without any meaning. Okay, from the oil you need to start extracting the essential ingredients, and then we let out all the unnecessary things. The same way the data is the new oil way back in 2011. Okay, and now in 2020 we have another term called dataism that we'll see it at the end. And this is the 5 V's of big data. But let me tell you, the V's has increased a lot. I think this is a very old PPT. Like we have almost 7, 9, 11 types of V's. Okay. Apart from this volume, velocity, variety, veracity, value, there are lot many V's involved in big data. Okay. So as you could see that the first one is a volume, like how much raw data are you gathering? Lots and lots. The velocity, like the change over time. Like this one, you could consider with respect to a time series data, how the situation was in a certain period, how the situation is now, how the situation is going to be in the future. That way, the data keeps changing with respect to time. Considering the same old corona case, it was very in a peak stage in 2019. Now it is like, okay, in another 1 year, you will forget the word corona. This is how the data has changed over a period of time. And the next one is variety. We have lots and lots of different types of data, right from a Excel sheet, a PPT, a Word document, a picture file, a video file, a music file. Like these are all different types of data. And each type of data would require a different type of processing. The next one is quality of the data. Okay, so for sure it is guaranteed that when someone give you a small Excel sheet, or like even if I give you a PPT after the end of the session, if I share this PPT with you, how could you tell that this data is quality or not? When I put all the essential informations, right now I have put only the V's. I have not mentioned what does a volume mean, what does a velocity mean, what is a variety mean. While I'm literally explaining you in oral words, but that is not put in the PPT. Now you would say this PPT is not of good quality. There is lot of missing informations. There is lot of spelling mistakes, grammar mistakes. Then you would say the quality is not good. The same way when you get a small Excel sheet of maybe the corona case only, let's consider the same again. When you take statistics of the past 2 years of corona, people started gathering information from each of the COVID patients. I think you would agree, right? They started getting your name, age, blood group, from where, which area, everything they started gathering because they need to analyze that. At the end of the day, they will give you analysis stating out of all the corona cases, let's assume IT engineers got the most of the cases. Maybe IT engineers got affected by 90%, teaching professionals got affected by 80%, students got affected by 70%, homemakers by 50%. That way, they would give you some statistics. For this only, they gather so much of data from you. Okay. Now, you would know that not many people are sharing a true information. Right, my own grandfather, when they asked them, he didn't give like what his actual job is. Okay, because he felt that it is unsafe for him to say the job where he's working, because he feared that they would go and complain to his office and they would quit him from his job. So much of things, and people don't actually really reveal a proper information. Sometimes people would say, I'm not ready to share my information. Talking about the rights of constitution and so much, they would say, I'm not going to give you my details. In that case, if you see the Excel sheet of a corona patients, Many details might be missing, many details may be incorrect, many details may be of no quality. Okay, so this is what the veracity means. Okay, the quality of your data. Now, when you start analyzing the COVID data, the first thing you have to do is clean your data set. You have many missing values, either remove it. You have certain wrong values, remove it. That way you have to pre-process the data, clean it to a proper format, and then start doing the analysis part. Okay, so that's what the veracity is. And then finally, it's value, information for decision making. Okay, like assume that like assume that I was affected with COVID. Truly, I was not. But then let's assume that I was affected with COVID and they started gathering so much information from me. And assume that if they have collected my height and weight as well. Okay, they asked me like how much was your height when you were COVID affected, how much was your weight, and if and all if they are going to release a statement saying that from the analysis, it is inferred that people who were overweight were affected by COVID. That is okay. It makes some sense because when you're overweight, then your health is totally in a bad condition. Then maybe the chances of you getting COVID is really high. On the other hand, if someone says to you that it is inferred from the COVID data that people over 5 feet is affected by COVID the most, does this make any sense to you? Now, this is what the value of the data is. Okay, if and all if they say that weight affects COVID, sorry, COVID, sorry, a person's weight affects the COVID chances. It makes some sense, okay, because of overweight, unhealthy eating habits, unhealthy body condition, and people might be more prone to get affected. But when they say that people over 5 feet will surely get affected with COVID, this doesn't make any sense, right? So this kind of information for decision making is again important, right? So when you gather the data, you would gather all data. But then when you make it as an inference, when you release it as a information, then it has to be meaningfully done. Only that will add value to your data analysis. Okay. So coming to the basic definition of what is data science. So of all, this is what I love the most. So this is what I've put here. The future belongs to the companies and people who turn the data into products and not projects. Okay, actually, and in fact, what we're doing is turning a data into a project. But when you make it into a product, then that is where the actual value is. Okay, let me give you one small example. Okay, there was one guy who used to do mushroom farming in home. Okay, like he was my neighbor and he was doing mushroom farming in his very small bedroom. Okay, what he got was like he got something like bunk beds. You understand, right? Like one on top of the other. Likewise, he got two shelves. Okay, just for imagination, I'm saying you as bunk beds. Assume he had two bunk beds, and on that he was having some kind of sack. Okay, and in that he put some fertilizer, some kind of mud, some kind of straw, and he started growing bags and bags of mushrooms. Okay, so one second. So this guy, when he was doing, like initially he didn't have any idea of how to grow a mushroom and all, and he took a very small workshop, 1 day workshop, or that was organized by Government of India. So he took up that mushroom farming and one second, I'll just show you that picture as how it does look. Okay, this is how it is. You could see this picture, no, like this is not so clear. Okay, almost everything is the same picture only. As you could see, no, like this is all small sacks. So all they did was like put so much of once again. Okay, likewise, rack wise, what they did was like put each and every sack here and there, and he started growing like in just 4 shelves. Okay, and you know, like this mushroom farming doesn't require so much of technologies and all. Very simple to do. Like you just need to attend that 1 day workshop, and that's more than enough to gain so much good profit. Okay, and he started. The only problem is with the temperature. Fortunately, he was in a good city where the temperature is modest, so the farming went well. Okay, initially with zero budget when he started this, like he started this with a very small amount of like I think less than 5,000. Okay, it was like very less amount only, if not It should be like somewhere around 3,000 to 5,000. He started this business, and all that he did was like started doing it as a growing part. Okay. He just wanted to start it for a small local community. We have a small shop over the corner of the street. So he started selling there. And then, the profit was really good. And he felt that this is more than enough for him to sustain. While after a week, like after a year or so, when we told him, like not me actually, but people started telling him that this is just like a project where you're trying to grow mushrooms in your home and you're selling it. Let's make it into a product. Okay. The same thing, what he did was like, from being a one-time employee, like he did everything all by himself. Then later what he did was like, he employed 2, 3 females, like ladies, and then he started doing mushroom chips, mushroom pickles, mushroom, lot many items related to mushroom. Now what happened was like, now he's like a businessman and he has employed people to work there. And the same product, instead of selling as a mushroom, he turned it into a mushroom pickle, mushroom, so much more items, something, whatever people were interested of. You see that that ladies, that female ladies, they were good at cooking. That's it. But they didn't have a good job to work with. And he found the right people, made them make dishes with items with mushroom, and he sold it there. Earlier, 1 year back, when he was getting a turnover of like 50,000, it turned somewhere to 5 lakhs. Okay, this is what the value is. Again, the same goes with mushroom, sorry, data science. Like when you understand data science, it shouldn't end up with a project, but it has to end up into a product. Okay, product has much more value than a project. If a mushroom cost gives you a turnover of 50,000, a mushroom product gives you a turnaround of 5 lakhs. That's what the difference is. Okay, and this is one of my favorite definition of data science. So data science is a science which uses computer science, statistics, machine learning, visualization, HCI to collect, clean, integrate, analyze, visualize, interact the data to create a data product. Okay, and you could see almost all the subjects name given here: statistics, ML, computer science, human computer interaction. Like these are all the courses we would be studying in college, but you wouldn't believe that all these courses are really trivial to understand a data science. Okay, so what you basically do is gather the data, clean the data, integrate the data. Integrate means what? Like you have to understand how one data is affected by the other data. Hope you might know the word like correlation, coefficient, covariance and all. Okay, so when you have like 10 different columns, you need to understand how the first column of data affects the second column of data. Which two columns are strongly bonded, which two columns are not so strong. Everything you need to understand, that kind of integration. Analysis, visualization, interaction, everything required. And finally, the data science should yield a data product rather than a project. Okay. So the goal of data science is to turn a data into data products. And now one important difference between business intelligence and data science, because the second important concept required for a data scientist is business intelligence. Okay, so in terms of business intelligence, you would just understand what was the past. You would understand, dig up and understand what the past was. Based on the past, you would try to improve your future. But in terms of data science, you would dig up the past, you would understand the present, you would predict the future. Okay, so this is what basically the difference. And these are some of the very interesting books related to business intelligence. Now coming to the major advantages and disadvantages of data science. Okay, so the major advantages is, as I showed you in the synopsis of poster, by 2026, we need 11.5 million data scientist jobs. We have so much of positions open. So it is highly in demand, abundance of positions, a good paid career, highly prestigious, of course. To be frank, like most of my friends ended up being in IT and right now they are like data scientists. And when I see them, I'll be like, oh my God, like she was like sitting next to me and right now she's like a data scientist. I would give that kind of vibe. And when she see me, she would say like, oh my God, we both flunked classes. We both bunked classes and we did everything. But right now you're a doctorate. You're a doctor, Divimina. Only I understand what is behind that doctorate. and only she understands what is behind that data scientist. When we sit together and say that, oh, there's nothing behind this doctorate, it's after all like DR, that's it. There's not much hype behind it. The same thing she says. We are doing literally nothing apart from doing a pre-processing stage. That's it. She's working with the TCS, so like it's a very big organization, as you might agree. And her part is very, very, very small in that. But she's a lead data scientist. Okay, so like actually the name is so prestigious, but when you understand it, it's not so much complicated and all. Unless and until you end up in a startup company where the number of people working in the organization will be somewhere around 5 to 10, only there you would work as a true data scientist. In rest all bigger organizations, your job is very minute, very small. Okay. And the next one is versatile. Like, of course, you would agree to this. And coming to the disadvantages, it is a blurry term. Okay. We spoke so much right now, like what is a data science, everything. But I'm 100% sure that even now you wouldn't be sure of what a data scientist is. Okay. Might be, that data science is a combination of statistics to business intelligence to machine learning. You would know that basic definition. But apart from that, we don't know still the difference between a data science and data analysis. Data science and machine learning and deep learning, AI and data science. We still don't know the difference between all this. Okay, so till the end, it's going to be a blurry term only. And mastering data science is near to impossible because you would agree to that. There's so much things required to master a data science, right from computer science to human computer interaction. If you understand all these concepts only, you are a master in data science. It's beyond a lifetime achievement. Next one is large amount of domain knowledge is required. Of course, arbitrary data may yield unexpected results. Okay, so arbitrary data may yield unexpected results. So, you might have heard of these jokes and all, like every people, like when you do a project, you would know that project works in team wise, where like one team would be doing one module, another team would be doing another module, and there'll be one team who would sit and integrate all these modules, combine all these models, and they will throw it on the testing side. The actual headache is in the testing side. Okay, so that's they are the ones to actually suffer. But of course, they would just simply say that the modules are not integrated properly, the code isn't running. But when things happen arbitrarily, the result is not going to be as expected. Okay, so everything starts from the data gathering part. As I told you, if you're affected with COVID, when someone gets data from you, it's so meaningless to get the height of a person. This is what the data gathering part is. You need to understand all the relevant factors, relevant fields required, essential fields required, and avoid all unnecessary things because there is no shortage of data. Already we have so much of data. We don't want to add up to that. We need to collect only whatever that is essential, whatever that is required. Okay, so arbitrary data may yield unexpected results. So the major disadvantage of data science is starting from the very stage of gathering part and cleaning part. Okay, and the major problem is the data privacy. I'll tell you what it is. Okay, from the beginning of the session, I was telling a term called dataism. That's what the data privacy starts. Okay, the problem of data privacy. So these are the advantages and disadvantages, and this is how a data scientist looks like, obviously, and then the skills required for a data scientist. You could see literally almost all the subjects, all the courses, and all the keywords here, starting from maths and statistics. See, machine learning comes under maths. How many of you would agree that machine learning comes under maths? But it is actually indeed under maths only, right? The course and the course syllabus we have at universities level are not that way. Okay, so let me not talk about that. So next one is statistical modeling, exploratory data analysis, clustering, regression, and in the programming side, you need every computer science fundamentals, starting from what is computer hardware, software, DBMS, database management system, data visualization, Python, big data, R, and then domain knowledge is like business operation, how to work with the data. You have to be a problem solver. You have to be a strategic, proactive, cooperative trainer or thinker. Then also you should be interested in hacking. Then in terms of communication and visualization, the first thing that the primary requirement of data scientist is storytelling habit. Okay, like when you go to IT side, when clients tell their project requirement, okay, you will gather it. Assume that someone wants maybe someone wants some, what example? Okay, let's assume that someone wants a small two-wheeler, I mean electronic vehicle for his kid. Okay, this is what the requirement is. When they say the same thing to a IT guy, okay, because client is a person who goes and tell, I want you to design an e-vehicle for my kid of like 4 years. Okay, this is what his requirement is. He would tell everything with respect to his kid's attitude. Assume that the kid is like super duper, like the kid is going to be so cautious, and it is very sure that the parent is very sure that kid is not going to fall out of the vehicle. Okay, so what he would say is, my kid is like, he can manage that thing, so you can keep only two wheels instead of that extra two wheels we'll have at the back end. No, you don't have to keep that, because my kid is like so cautious, he already knows driving, so he could do that, this everything, and so design it in this way. This is what the requirement of the client is. When you take up the same thing, and as a project leader, when you communicate this requirement to your project team, you would say that we have a new project coming up, and the project is to design a e-vehicle for a 4-year-old kid, and the kid was like this. So this is how you shouldn't say. Actually, it has to be built it up in a storytelling way. And of course, the model that you design, maybe for this kid, if you avoid the two extra wheels, it should be designed in a way that it is adaptable, it is flexible for all other kids of the same age group. Okay, so that's how it has to be. Like at the end, what I'm trying to say is, the model, the product, whatever it is, has to be adaptive. Okay, so if you keep developing projects for individual clients like this, then it's like, it's not a business thing. Okay, so storytelling skill is one important thing. Like you need to relate it with real time. Okay, like this parent may be like so proud of his son that he doesn't fall out of a vehicle, but it has to be told in a way that it could relate to a new real time story. You have to say it in a way that although this particular client doesn't want it, you would agree with me that a 4-year-old kid won't be able to handle the bike all of alone. And this is what the problems that could arise if and all, if it happens to fail, all that. Okay, it has to be related to a real-time story, and then it has to be conveyed. Of course, this could not be applicable for all projects, but as I told you, know, like that one session that we did recently, he stressed on that importance. How a project has to be communicated to a project team. Should it be told as a project, or should it be told as a story? When you tell it as a story, it has much impact. It has better understanding. It has better effect on the developers. Okay, so that's the first skill required, storytelling. How to convert a data into a decision, collaboration, knowledge of various tools like Tableau and so much, visual art design. Okay, so although we'll not be able to focus everything in this 30-hour session, but we'll try to touch upon maximum of the things. Okay, lots and said. We'll have a short video of what is data science. 1 second. Okay, when I share the video, someone please tell me if you're able to hear the audio of the file as well.
What is data science?
Yeah, ma'am, we can hear.
Yeah, okay.
What is data science? Explained in 5 minutes. Hi, this is 365's new series of videos in which we will try to explain a given topic very quickly. In fact, we'll use a timer to keep our speed up and try to fit the video in 5 minutes. So, which should be the first topic that we want to cover? Given what we're called 365 Data Science, we'll start with what is data science? Hope you're ready. Let's start the clock. A few years ago, a shrewd journalist came up with the headline that data scientist is the sexiest job of the 21st century. According to Glassdoor.com, data scientist continues to be among the most desired career paths today. Ironically, the term data science, which was first introduced in the 1980s, remains confusing for many people even now. A large number of individuals, particularly the ones outside the field, struggle to understand how data scientists help companies around the world and why their services are in such high demand. There are a few key reasons for this. First of all, data science is an interdisciplinary field. Its true foundations are in statistics, mathematics, computer science, and business. So, it is difficult to draw a clear separation line indicating what lies in the realm of data science and what doesn't. On a few occasions, people have claimed that data science and statistics are the same thing. However, we'd argue that data science is broader, as it grows out of statistics to include topics that are apt to deal with digital and big data. Another frequent misconception is that data science and AI are interchangeable terms. AI designates a model, a machine if you will, which tries to mimic human behavior and produce human-like decisions. It sometimes leverages data science methods such as deep learning, but is not confined solely to them. For example, symbolic reasoning is a type of AI that does not necessarily have to be characterized as data science. Machine and deep learning are important domains within data science, and so is statistics. So, data science is in fact a very broad discipline, which continues to expand with new data-related needs. Let's briefly pause the chronometer before we continue. In the second part of the video, we will talk about the key aspects of the data scientist profession. But before we do that, please like this video and subscribe to our channel so that YouTube's ML algorithms won't keep you away from our videos. Having said that, let's continue with the video and consider a few important aspects of data scientists' work. Type of data used. 1. Activities performed on the job. 2. Time allocation. 3. Key skills. 4. Frequently used data science methods. What type of data do data scientists use in their analysis? The answer is both structured and unstructured data. Structured data comes in the form of Excel spreadsheets and CSV files. To put it briefly, it can be organized in rows and columns. Examples of such data are client tables and spreadsheets with transaction information. Unstructured data, on the other hand, is everything else. Images, video, and audio files, all types of other data we can have. Reportedly, unstructured data represents more than 80% of all enterprise data. So every data scientist worth their salt should be able to take advantage of it. Which are the types of activities a data scientist carries out in their job? It depends mostly on company size. In smaller firms, a data scientist might be the only data person, and therefore will have an end-to-end ownership of data analysis processes. In larger enterprises, there will be a higher degree of specialization, as the company is able to afford more resources. The main activities that a data scientist can perform, but not necessarily does in a business environment, are data collection and storage, data preprocessing, also referred to as data cleaning, data organization, data visualization, and the creation of KPI dashboards, experimentation and A/B testing, statistical inference, building ML models, evaluating ML models, deploying ML models, and monitoring how ML models perform. Considering these activities, which are the duties that take the most time? Ask anyone in the industry and you will hear the same answer. They'll tell you they spend 80% of the time in an effort to make a hypothesis, find the necessary data, and clean it. Only 20% of the useful hours are dedicated to performing analysis and interpreting the findings. And what about the key abilities a data scientist needs? Of course, the profession is multifaceted, but here's our top 5. Very solid knowledge of statistics and mathematics, computer science skills, business understanding, analytical abilities, and communication skills. Some of the most frequently used data science techniques are statistical inference, linear regression, logistic regression, machine learning techniques such as decision trees, support vector machines, clustering, dimensionality reduction, deep learning methods, supervised, unsupervised, and reinforcement learning. However, we should remember that regardless of the method, a data scientist's end goal would be to make a meaningful contribution to the business, to create value for the company. We can distinguish among 2 main ways to do that. First, help a company make better decisions when it comes to their customers and employees. Netflix and YouTube are able to recommend you the content you want to see next. Your telecom operator knows when you are more likely to switch to a competitor, and banks use data science methods for fraud detection. The other major way in which data science can add value to a business is through the optimization of existing operations. For example, a logistics company might benefit from an improved delivery schedule, while a manufacturing firm could use predictive analytics to foresee maintenance needs without risking production stoppages. And that's it. Data science explained in almost 5 minutes. We tried to win the race against the clock, but more importantly, we hope you learned something new. Let us know how we did in the comments and
So, okay. So, like, I don't want to repeat the entire video again, but 2 things that data scientist would focus on is the first thing is being some prediction kind, like as they were saying, like you like starting from customer retention problem, like when you are a shop owner, you want to understand how many customers are you going to retain for the next year. Okay, so starting from this kind of prediction to a lot more, talking about the pandemics and all, data scientists should help with the prediction models, followed by the optimization. Right now we have so much very good systems already running, but again, every system would definitely have a loophole, or it will suffer from a very small area. Okay, like talking about the delivery system, we have Amazon delivery, Zomato, Swiggy, we have a lot more. Okay, like right now, though they have invented something like 10 minutes delivery, if not, the money would be refunded. So much more is coming every day, but still there is a lot of problem in the delivery system. Okay, even yesterday I was facing a problem with one of the first price shops. So this is the kind of place where you could optimize the model. Optimization is a place where the result is already good, but still you want to make it better, from good to better to best. Okay, that's what optimization. So these two are the major areas where we touch up, where we would require a data scientist is. Okay, so these are other important terms that I would want to talk about. But before that, we'll just have a small difference and all. Like this one figure, I want you to see. So as you could see, no, like this is the present and this is the future, and this particular part is the past. Okay, so when you see, when I say data analytics, that's like the broadest term of all. And you see the data science is somewhere in between like inside the data and advanced analytics. Okay, it started with AI, but most of you would think that AI is the broader term and within which only DL, ML is coming. But AI is the core of the heart. I mean, it's the heart. And surrounded by that, we have ML, DL, and everything. Business intelligence, data science, data analytics. And when you combine all this with the requirement of business, then that's what an advanced analytics is. Okay, of course, every analytics would end up into some kind of business only, some kind of people requirement. Okay, so these are all what we are talking, what we are studying in a university level. This is not taught here, but this one has to be inbuilt. You need to start understanding what a business is, what a business intelligence is, everything. And then when you combine these two terms, it comes into an advanced analytics. Okay, so this is what the major domains involved within advanced analytics. And here we have certain differences between what a business intelligence and business analytics is. So, and here we have another difference of what is data analytics and what is data science. Okay, so maybe we'll see this difference alone. The major difference, one word we could say is, in data analytics, we work with structured data, Excel sheets. We have not touched anything beyond Excel sheets. Okay, so when you take an Excel sheet of iris classification, housing price prediction, customer fraud prediction, loan prediction, loan repayment, everything we get is what an Excel sheet. From that Excel sheet, what you're going to do is, if this is all the characteristics of a particular person, then he's going to retain in the shop. If this is what the particular person's bank account detail, then he's not going to repay the loan. That way, when you work only with the structured data, then that is data analytics. On the other hand, in terms of data science, you work mostly with unstructured data. Okay, that which does not have any particular structure. Okay, assume that if I show you 1,000 images, 1,000 random images, it is purely unstructured. When I start classifying them under categories like dog separately, human separately, objects separately, roads separately, and when I categorize all the 1,000 objects into different classes, you would think that that is structured. Again, it is not structured. If you start considering a dog, a particular class called dog, and you would start categorizing them again based on the breed of the dog, based on the color of the dog, based on the nature of the dog. So likewise, it keeps narrowing down. So we would say that all as a unstructured data. Okay, this is a small example with images. The same thing happens with videos, music files, and lot more. Okay, so data science mostly works on unstructured data. And with respect to data analytics, statistical and programming skills are not much needed, because if you want to be a data analyst, it is fine even if you have zero programming knowledge. On day 3, like I think on Friday, I'll be talking about codeless data science, where you don't need any programming knowledge skills to be a data analyst. Okay, we have many tools, online tools itself, that is open source. Okay, like even if you're doing right now capstone projects and all, for that you could build thousands and thousands of projects in less than 10 minutes with that codeless data science tools. Okay, so for a data analyst, you don't need any programming knowledge or statistical skills to execute and get an output, not required. But on the other hand, if you're a data scientist, programming knowledge is a must. Okay, so this codeless data science, which means no programming knowledge, is all related to data analyst only, and for data scientist it is mandatory. Okay, and so that's the basic difference. Other things let's not focus much on. And this one, I think, difference between a machine learning, data science, and data analyst, not required much. So what are the different skills required to become a data analyst? Okay, you would understand that we need mathematical statistics. You need an understanding of R, Python, data wrangling, Pig, Hive, lot more. But let me tell you, all this is not really though required for a data analyst. As I told you, data analyst can also work as a codeless data scientist. Okay, so we have 2 sessions on codeless data science. Maybe before the sessions, I'll ping you because I know most of you are here without any basic knowledge on programming, because we have participants right from first year to PhD level. Okay, so I would say that not everyone is well versed in the programming knowledge. That's why we took these 2 sessions specifically. Okay, when we saw the participants list, like it was broad, MS, BTech, PhD, first year, final year. So, like although we cannot do specific sessions for each branches and batches, but we have to touch upon everything. So for those who don't have good knowledge on programming skills and other techniques, we have 2 sessions on codeless data science where zero knowledge is required for understanding all the tools. It's a simple drag and drop tools only. You could build numerous beautiful projects. At least for a first year level, you could do like so interesting projects with those tools and all. Okay, so that we'll see it on Friday and one other day. And this is the skills required to be a machine learning expert. Like you need to understand computer fundamentals, programming language, data modeling, probability, statistics. For this, I wouldn't vouch because all this required really programming knowledges and all. And to be a data scientist, you need so much of multiple knowledge, like starting from what is machine learning, understanding statistical tools like SAS, Scala, Python, R, then SQL, unstructured data working, so much we need. So this is all the different knowledges required for each of the domains. And then talking about the final thing, DIKW. Okay, like how do you start with the data? Like you just see this picture, that's more than enough to understand this. So data is something like this. You have numbers, you have words, everything is totally raw. They are not categorized. Okay, they are totally unorganized. When it is so, we say it as a raw data. Okay, on the other hand, when it is the information from that raw data, you start understanding who this data is for, what the data is actually, when it started, where it is going, all these questions. When you start asking to your data set, then that's where you start understanding the information. Okay, whenever I say data, please relate it with some real-time examples. Maybe take the corona case only because everyone are very familiar with that particular concept. Okay, so when I give you an Excel sheet about corona case, so when it is like this blurred, you need to start understanding what this data is. It is about corona. Who is it about? It is about corona patients. When it started, 2019, where it went to almost all the countries and places in the whole world. Okay, so when you start asking these type of questions, the actual information starts to come out. Okay, so data means it's raw, it's not organized. If it is information, it is organized. Okay, and the next one that you have is knowledge. Okay, so from the information, you would start telling something, right? When you understand the Excel sheet, you would say, okay, when I analyzed the Excel sheet, I found that people over 80 years or people over 60 years are more prone to corona. Then kids less than 5 years are more prone to corona. This kind of inference, when you start making, that is what a knowledge is. Okay, how pieces of information. What do you mean by pieces of information? It's like the age, the particular country, the weight factors, other things. Each individual small pieces, when you relate them and when you tell one particular line saying that if a person is from suburban area and if he's overweight and if he's like having medical history, then he tends to have 100% corona chances. This is what the knowledge is. Gathering minute pieces of information and then saying them out as a one particular knowledge. Okay. And the final thing is wisdom. Okay, this is where the entire world, including data scientists and everyone struggles. We stop it with this particular part. Like we stop it with the knowledge part. When we say some inference, we stop it with that. But the wisdom is, why do you do this? What is best? And then when you apply this knowledge to get a proper action, or in terms of a product, that's what the wisdom is. Okay, so like you would say that, okay, I understood who is all prone to a corona, who is not prone to corona. That is not an wisdom is. Okay, you have to make it into something even for meaningful, and make it into a future predictions, everything. When such things happen, then that is what the wisdom is. Okay, so this is what the DIKW pyramid is: data, information, knowledge, and wisdom. Okay, so going to the final topic of the session. So we'll be talking about just two topics now. One is datafication and dataism. Okay, these two are the happening words right now. Okay, so what is the datafication? Okay, so like right now, as we would say that data science, big, like earlier, big data was a very big word. Then big data went somewhere, data science came. Again, data science is still in picture, but still the next keyword is datafication. Okay, so although the term is ugly, why? Because datafication means something about the data. Okay, earlier the data were all there, but the data were hidden in the dark. Right now, we are bringing the data to the light. That's it. Okay, the data that were lying unused for so long years are now being brought to the light. That is what a datafication is. Okay, so you see the definition. It is taking a process that was previously invisible to making it into a data. Okay, which means nothing but like we've been already tracking people about maybe that as I was talking about the sponsored search. No, we usually track people when they're browsing, we track their history. When they're browsing, we track so much of their details, where they're going, what they're doing, what is their average span of usage, everything we track. Okay, everything we track, but we haven't used them. But right now we start using them and start understanding the opportunities that could be used out of the tracking. We also start understanding the challenges there. Okay, so assume that Fitbit band. Okay, when we go for just jogging, running, we have this Fitbit bands and all. No, when you wear that band, it starts monitoring your entire body. How many, starting from how many steps you took, how many calories you burned, and what is your pulse rate, heart rate, everything starts monitoring. That is what we've been doing in the past. That's what we've been doing right now. But in terms of datafication, you need to start understanding the opportunities and challenges out of the tracking. Okay, that is what the datafication is. It is similar to some ways to the notion of dark data, because the data was in dark, it wasn't explored, it wasn't understood, it wasn't analyzed, and so the data was in dark. But right now we are bringing them into a lighter area where there is so much of visibility to understand their opportunities and challenges. Okay, all the data that was ignored all these times are now bringing into, or are now brought into light in order to understand that. Literally, we are trying to datify our everyday life. Datify means making your everyday life into a data, right from everything when you wake up to the last moment when you go back to your bed. When you start gathering every information of your data, then that is what is datifying your life. Okay, that is what the current century is about. We are trying to datify our entire life. Everyday aspects of the life, we are trying to datify it. Okay, so you see this particular example. Okay, the earlier days, when you want to go for a walking, jogging, all that you would do is like have a timer on and then set it as like 30 minutes, start running, jogging. Then once the timer goes off, then you would stop running. This is the maximum thing we did in the earlier days. But right now we have this Fitbit bands and so much trackers, which could count the number of steps that you took. Like even if you don't have a Fitbit band, if you have a smartphone like Android or something, like we have this options called as Jovi and so much more apps and all. When you when you take your phone in hand and then you start walking, it will count the number of steps. Though it's not going to be 100% accurate, but still it does. Okay, like I'm not so technological related girl and also, but then like once I got a new phone, then there was one app called Jovi which started tracking the number of steps I took. It was like showing somewhere around 300, and I was like, what the, like how on earth, like I could walk only 300 steps a day. Then I understood that, okay, fine. So only when I carry the phone on my hand, it tracks the number of steps I take. So if I want to go for a walking, instead of going for a Fitbit band, my phone is more than enough for me to count the number of steps that I took. Although it's not accurate, again, I tell you, but still that's enough for me. I'm not like a sports person to count the number of steps I take every day. But then if I want to, if I have a target like 1,000 steps a day, if I want to track it, my phone is more than enough to do that. We have also so many useless and useful apps to track the number of step counts and all. Likewise, everything that we do is getting datified. Earlier, Netflix and all, no. Now you know what is Netflix better than anyone else. Like I'm not into Netflix and all, so I don't know anything about Netflix. But one thing that I know is it's subscription based. You subscribe and you get channels, you get videos, everything for free for a few months. Then again, you need to pay. That's how it's currently is. But in earlier days, Netflix was working on DVD basis. Okay, they would have the DVD of so many good movies, old movies, everything. Fine. You have to buy the DVD for rent. Okay, you have to buy a DVD for rent and you can keep it as long as you want. Like you have to buy it for like 3 months and then you can leave it for rotation, get some paisa and everything. That's all on the other side. But it was working on DVD basis, putting the movie in DVD and giving it for rent. And the next time when you want to buy a new DVD, you have to return this DVD and get the new one. It's like exchange. At one point of time, you can have just one DVD. Okay, so this is how it was working way back, like 20 years or some 10 years back. But right now, you know how things are working. Okay, and we have this DVD boxes and all. Like if you put coins, it will give you DVDs and all. So we have that kind of automated machines earlier for DVDs, but now hardly anyone has this DVD. Like in another 10 years, I think people will ask us, what is a DVD? The requirement has gone. Okay, so this is all about datification. We moved from a DVD disc to online subscription. So this is what datification is. We moved from a physical timer to Fitbit bands, sensor bands. This is what datification is. Okay, so like I just told you two examples. Likewise, people are trying to datify each and everything, each and every aspect. Okay, like I don't want to talk about any weird examples, but you could think, let out your imagination and think what all aspects of our daily day-to-day life are not datified yet. Okay, assume if you're bathing and now people don't count the number of liters of water you take every day to bath. But in very few years, that also will be datified. Okay, they will measure the amount of liters you took every day for your bath. This is what datification is, and this is what dataism is. Our future is going to be dataism, where they are trying to gather data out of every small things that we do in our day-to-day life. Okay, and the rise of dataism, like, is it a threat to freedom or a scientific revolution? Okay, one guy, okay, this guy called Homo Deus. Okay, right, like way back in 2016, not so old, like in 2016 only, he told we have to move to an era of dataism, where we collect all the data, where we release all the data publicly. Okay, right now Google is gathering our data. They just give you one terms and condition. If you check that box only, you'll be able to install the Chrome in the very first place. And in that, we don't even hardly read that statements and all. But they would say, I agree to gathering my data, browsing data. I agree to gathering my cookies. I agree to gathering my passwords though. So everything we would agree by just simply clicking on the checkbox. And then Google would start gathering all our data. They are officially doing it. Likewise, this guy told, let's datify our everyday aspects and let's release it publicly. Because you cannot say an IT engineer can only think in terms of data scientist. Only a top tier university student can think in terms of data scientist. We cannot say that, right? Like yesterday, though, I saw in one LinkedIn post that one guy who was a school dropout in 8th standard, then he was like working as a security in some IT office. Then like he just understood the projects. He spoke with people on a general terms. He started to understand people, like he was like bit technical, not technical, but he was like more open type. People come and say, okay, this is the project that we're doing, but we are stuck with this point. And this security guard, he started giving suggestions that you could approach it this way, because they were able to tell their project as a story to this guy. And without having any good degrees, he's still able to understand their project as a story related with real time, and he was able to tell suggestions. Okay, then seeing his intelligence, they started giving him basic training. Then he was promoted as a clerk, then to some other bigger designation. And now you know what? He's running a big business and he's one of the analysts there. Can you imagine eighth standard dropout school student is now a business analyst and who's running a multi-crore company? Okay, this is what the thing is. So this guy, Homogeus, he told that let's datify the everyday aspects of our life and let's release it publicly. But you know, even if the data is hidden, we have so much of very good hackers who could hack literally everything. And if and all if the data is released publicly, is it a threat to our freedom or is it going to make any scientific revolution? So this is the biggest question mark right now. Okay. Okay, so the very last point I want to say is humans were special and important because up until now, okay, so humans were special and important because till now we are the most sophisticated data processing system in the entire universe. Okay, earlier we didn't have any artificial intelligence, any data science, any machine learning. We could only do the prediction. Okay, like we had astrologers who, or we had some novel people who would think that this could happen in the future. This is what, okay, like we had our very old own grandmothers who did all the medical miracles, but it was the past case. Humans were the most sophisticated thing to process the data. But right now, humans are nowhere. Now we have big data, we have machine learning, we have deep learning, who could provide more sophisticated results for the projects. Okay, so when things are going out of our hand, let's datify everything and let's give it to the public. Let them make some revolution, evolution, interpretation out of these data, and that's where the world will start growing. That's what this guy's philosophy is, but I don't know how far it's going to be true. Okay, the last topic is on violences. So you might have heard of the very first word, surveillance, which means monitoring. The second word we have is data violence. The third is surveillance and violence. Okay, so much more, so much many words regarding violence. And if you say surveillance, it's something related to satellite view where you record the entire thing, where you monitor everything on a very broader level. And when it is data violence, it's like a street view. Like these are just examples. Street view means focusing on only one particular area. Satellite view will focus on whole of the place, whereas street view will focus on only one particular area. And surveillance will go down and it will focus on only one particular person, monitoring a single person. And one other thing is violence, which will monitor one particular part of a person. Okay, going from the whole place to one particular area, to one particular person, to one particular organ, maybe the heart rate, the pulse rate, only that. Okay, these are the four surveillance we have. So the basic definitions you have here, you might know this already. Surveillance means visual monitoring system. So this would take images, videos and all and keep track of what is happening. The data violence means it is an automated and efficient personal data collection system. Okay, so we are gathering the data of a particular, not particular person, but of a particular community. Okay, that is data violence. Surveillance means wearable computing devices and technology. So when you wear some sensors and all something, you start gathering the audio, visual and sensory data of a particular thing. And final thing is violence. It's related to RFID chips and all, where you track the particular person's location and everything. Okay, so now we are in the era of data violence. We haven't moved to surveillance and violence and all. Data violence. We are in the process of dataism, where we need to incorporate the idea of data violence, which means collection of personal data of a particular people. Okay, that's what it is. The basic definition is it is a digital monitoring of people in order to understand their behavior. That's it. Monitoring, gathering of a particular person's details in order to understand their behavior. And every time they say that we are collecting the data, we are doing it for the scientific community. We are doing it for the social community because we want to do something else. Just because they were able to gather the COVID patients' data, they will be able to predict the future. They will be able to say that if these are the characteristics, then we should be ready for the next pandemic. All this they were able to do because they gathered our data. If every person on the earth starts saying that, no, I was not affected with COVID, I'm not going to say my details and all, then where things will go? Unless and until there is a data, there's not going to be any predictions. Okay, so that is what the ultimate aim is going to be. Like right now, we want the area to be focusing on dataism, where we datify our everyday life, everyday aspect, collect data, get the data, and then start understanding. And guys like this boy, like Homodu, say that not one particular community or not one particular department can analyze the data. Let's release it publicly for everyone, and let's start understanding it in a much better way. Okay, so that's it for the class today. So we started with what is data science and some broad terms related to that. And the most important thing that we discussed is datafication, dataism, data violence. Okay, so those three things. Fine, so I'd like to stop here. So let me give you a reminder, tomorrow's session,